Okay, next we start with the fundamental triangle between the points x sub 1, y sub 1, and x sub 2, y sub 2. Again, you should be able to instantly draw this and label it. And then, very quickly, see what the rise is. Well, the y-coordinate goes from y1 to y2. So if we go from here to here, the rise is y2 minus y1. And if we go from x1 to x2, we get the run. That end looks like an H, looks like R-U-H. Okay, the run, which is going to be x2 minus x1. So the slope of this triangle is the rise divided by the run. That's y2 minus y1 over x2 minus x1. Somehow I wrote x2 minus x2. And I certainly hope nobody believed me when I wrote that. So let's fix that. I think everybody knows what this is. Okay, now this is not a formula you want to memorize, although, well, it's fine to memorize it. Fine to memorize this. But you need to understand what it means, and the way to understand what it means is to know how to do a fundamental triangle. Again, a very early skill, the first or second skill we built in this course. Okay, now, if I want to say, well, to say that the slope between x1, y1, and xy is equal to the slope between x1, y1, and x2, y2 is to say what? What's the slope between x1, y1, and xy? Well, here's our fundamental triangle for x1, y1, and xy. The rise is y minus y1, the run is x minus x1. So we can say that if the slope between here and here is equal to this slope, which is saying that if a slope of a line containing x1, y1 is equal to this slope, well then our equation would read y minus y1 over x minus x1, the slope of this fundamental triangle, equal to y2 minus y1 over x2 minus x1, which is the slope of this triangle. And in that case, well, we can multiply both sides by x minus x1 and get this. And this is a big old formula that nobody can ever remember, but that we teach people expecting that they'll know it when they need it. Well, you can always look it up, but that's a step that gets in the way. If you don't know it, you can't instantly use it. Okay, so from setting the slope of this fundamental triangle equal to the slope of this fundamental triangle, we get this relationship, which tells us the conditions on x and y so that they lie on a line through this point having this slope. Well, that line goes through this point, its slope is the same as the slope of this triangle, so it's a line that also goes through this point. So a line through this point and this point will have an equation given by this relationship. We do a little algebra, we solve this relationship just by multiplying both sides by x minus x1, we get an equation that says y minus y1 equals this slope times x minus x1. So that's the slope of an equation for a line through x1, y1, and x2, y2. If you're given the 2 points, then you know what x1 is, you know what y1 is, you know what x2 is, you know what y2 is. So you can replace y1 with whatever y1 is, y2 with whatever y2 is, x1 and x2 with whatever they are. So if you want to find the equation of a line with through these 2 points, well, let x1, y1 be your first point, negative 3, 5. Let x2, y2 be your second point, 9, 7. So that x1 is negative 3 and y1 is 5, and x2 is 9 and y2 is 7. So we plug negative 3 in for x1. That occurs here and here. So we're going to have a negative 3 here and here, and there they are. There's negative 3 and there's negative 3. y1 is 5, so we're going to have a 5 wherever we have y1. That's going to be here, there it is, and here. There it is. x2 is 9, and that occurs here. So right there it is. y2 is 7. That occurs here, and there it is. So now we've substituted the coordinates of our 2 points carefully, systematically into this formula. We have some idea where this formula comes from, and maybe easier to understand where it comes from and be able to write it down that way than to try to memorize it. But whatever works is okay. And then we can just substitute our coordinates in, we get this. And then we solve for y. Okay? So 7 minus 5 is 2, 9 minus negative 3 is 9 plus 3, which is 12. So this fraction just becomes 2 over 12. X minus negative 3 becomes x plus 3. And y minus 5 is still over here. Well, 2/12 is 1/6. So we'll leave this y minus 5 as 1/6 times x plus 3. So then we add 5 to both sides. We get y equals 1/6 times the quantity x plus 3 plus 5. Then we multiply through by the 1/6. We get 1/6 x plus 1/6 times 3. That's 3/6, which reduces to 1/2. And then we add the 1/2 to the 5 to get 11/2. And we get our equation, y equals 1/6 x plus 11/2. There's the equation of our straight line. Again, we can memorize this formula, okay, or we could memorize the formula, I'll write one here, y minus y1 equals m times x minus x1. It's the same formula, but m is the slope between our 2 given points. So, well, if we know how to find the slope between 2 given points, we can just use m here. We don't have to use all these symbols. So this might be a little more useful. And this works if you have the coordinates of a point, x1, y1, and know the slope. It works if you already know the slope and have a point. It works if you have 2 points. Then you can get the slope between those 2 points. And then you can use either point, x1, y1, or x2, y2. But I'm going to call it y minus y1, x minus x1. Okay. So that's how we get the equation of a straight line. That's a lot about the graph of a straight line, and we'll build on this next time.